All right, in this lesson, we are going to look at some harder applications of exponential functions. And so to start with a warm-up, these are some easier ones. It says $800 is deposited in an account that pays 9% annual interest compounded annually. Okay, and so find the balance after 4 years. And so when it's compounded annually, that means it's just compounded once per year. And so we use the formula A equals P times 1 plus R to the T. This is growing by a percent each year. And so our initial amount, which is P, is 800. And then our interest rate in decimal form, it's 9%, so we move the decimal, and it would be 0.09. Move the decimal 2 places to the left. And then T is time, and they're telling us 4 years. And so we need to find the future amount of the $800 after it has grown by 9% each year for 4 years. And so we can type that expression in our calculator. If you want to simplify the 1.09, that's an easy simplification. And then in your calculator, 800 times 1.09 raised to the 4th. And then keep 2 decimal places. And so our future amount would be $1,129.27. That 5 rounds 26 up to a 27. Right, and this next one, the number of bobcats in Frisco, Texas is doubling every 6 months. Currently, there are 200 bobcats in Frisco. When will there be over 10,000 bobcats in the area? Okay, and so we are starting with 200 and we are ending with 10,000. So our present value, 200, future value, 10,000. Okay, and then it is doubling every 6 months. This isn't growing by a percentage, so we're not going to have the 1 plus R situation. Our equation ends up being A equals P times 2, because it's doubling to the T. And then we're just going to keep in mind that we're measuring our time in 6-month periods, because it's doubling every 6 months, not every year. Number of 6-month periods. Okay, and so we want to know when we're going to reach 10,000 by taking 200 and doubling it every 6 months. And so we have to solve for the value of T. And so our first step here is to isolate the exponential expression by dividing by that 200. And so that would leave us with 50 equals 2 to the T power. And then once you've isolated the exponential expression, when you're solving for the exponent, that means you need to convert to log. So it's going to be log base 2 of 50 equals T. Log base 2 of 50 equals T. And that's what you would type in your calculator. And to get this other base, it's math, alpha, math, if you have a TI-84. So math, alpha, math, base 2 of 50 is 5.64. And remember, this is the number of 6-month periods. Okay, and so if you want to, I would multiply that by 6. And that would give us 33.8 or 33.9 months. And to convert that to years, take the number of months and divide it by 12. Write this in your notes, times 6 months equals months. And so then divided by 12 would give us the number of years. 2.8 years. Okay, and so whichever way they are asking you to answer the question, it says when will there be? It doesn't say months, it doesn't say years. If it said what year, that way you know just to convert to whatever measure of time. The important thing is keeping track of the fact that T is the number of 6-month periods. All right, so now we've done examples where we are compounding annually. We haven't done any examples where we're compounding any other amount of time. And so if you are compounding, say, monthly, semi-annually, annually, quarterly, you're going to have a different formula. It still looks like the formula we've been using, 1 plus r raised to the t, because it's going to grow. You just have to divide your interest rate by n and multiply your time by n. So you're noticing n showing up in 2 places in this formula that we've been using, and n is just the number of compounds per year. Number of compounds per year. So if it's quarterly, it's going to be 4. If it's annually, it's just 1. And so then our formula would turn back into our familiar formula. If it's semi-annually, 2. If it's monthly, 12. Trying to think of some other ways. Daily would be 365. Weekly would be 52. And I think that covers everything I've seen. Okay, and so A is still the future amount. P is still the present amount. Some call that the principal. That's what it's called in banking. R is the annual interest rate. I'm going to add in decimal form because they're going to give it to you as a percentage. And then T is still the number of years. Okay, and so here's a list of all our formulas. Last time we talked about growth and decay, where you're either growing by a percentage or decaying by a percentage. You would then subtract it. Here's our new formula with compound interest, adding in those 2 places. And then if it's compounded continuously, then our value of n is going to infinity, and that's actually where the constant e comes from. If you let the value n go to infinity, it becomes a constant that approaches e. And so e is going to show up into your formula. Some people read this as PERT, and so p times e to the rt. R is still that interest rate, t is still the number of years. And then if you see something dealing with half-life, your base is going to be 1/2. And then K is going to be the number of years in a half-life. So I'm just going to label that half-life, and we'll see some examples like that. Half-life time. Okay, so starting off easy. You deposit $2,500 in an account that pays 5% annual interest compounded continuously. What is the value, or what is the balance after 5 years? Okay, so as soon as I see that word continuously, that tells me I'm using this PERT formula. Okay, so I'm going to write that down. A equals P times E to the RT. Remember, E is not a variable. That's a constant, kind of like pi. All right, and so our given information is our present value is $2,500. Our R value is 0.05. T is 5. And that is all we need for the formula. So A equals P times E to the RT, just filling in those values. And so that is what we would type into our calculator. $2,500. And then to get to E, you're going to press second ln, and it's automatically going to put E with the exponent. There's also an E with your division key, but it doesn't include the exponent. We want the exponent, so that's the one I am using. 0.05 times 5. Okay, and so our final or future value is $3,210.06. Okay, this next example, $2,250 is deposited in an account that pays 6% annual interest. Find the balance after 10 years when it has been compounded monthly, quarterly, and daily. Okay, and so for monthly, we have monthly, quarterly, and daily. These aren't continuous, so we want the formula that has n involved. So that's A equals P times 1 plus R over n to the nt. Remembering that the n shows up in two places. Okay, and so in each case, we have our P value of 2,250. We have an R value of 0.06, and we have a T value of 10. Okay, and so when I set up my formula, A equals P times 1 plus R over n to the n, so I'm going to leave a blank because we're going to fill that in each time, n times T, which was 10. Okay, so I've plugged in 2250 for P, I plugged in 0.06 for R, and I plugged in 10 for T. Okay, we're going to do that in each of these cases, so I am going to copy this for each one. Okay, in the case of monthly, N is 12, so I'm going to have a 12 in this box. In the case of quarterly, N is 4, so I'm going to have a 4. In the case of daily, N is 365. Okay, and so we're going to type each of these into our calculator. Actually, we don't have to even simplify anything. I'll show you how to type this in very carefully. Okay, start with your 2250. Open your parentheses and do your 1 plus. Do your alpha y equals to get a fraction. And then you're doing your 0.06 over 12. And then raised to the 12 times 10. Okay, and so our final amount ends up being $4,093.64. For quarterly, we can go up and highlight what you just typed in and press enter, and you can just change the 12 to be a 4. If you want to just retype the whole thing, you can. And that's going to give us $4,081.54. And then for daily, I might just retype the whole thing. 2250, 1 plus alpha y equals 0.06 divided by 365. raised to 365 times 10. $4,099.57. Okay, and so you can kind of see that the more compounds per year, it actually increases the value in your account. Okay, for number 3, a patient had to take 50 milligrams of iodine 131 to treat his thyroid disease. Iodine 131 has a half-life of 8 hours. Okay, and so that 8 hours is going to be our K value. As soon as I see that word half-life, I know I am using the formula with the 1/2, and then you have T divided by the K. Okay, and so our initial amount is 50, and then we know K is 8, and then for part A, it says how much was left in his body after 1 day. Okay, and so T isn't 1. We're measuring in hours, and so we need to convert 1 day to hours, and so 24 hours would be our T value. And so when I'm using my formula, P is 50, and then we have times the 1/2 to the T divided by K. And so that means if a half-life is 8 hours, in 24 hours, that means it has cut in half 3 times, because it's half-life means it's getting cut in half every 8 hours. So after 8 hours, it's cut in half. After 8 hours, that part is cut in half. And so 24 divided by 8 simplifies to 3. You don't have to simplify it, but just so this formula makes sense to you, that means we've cut it in half 3 times. Okay? And so typing that into my calculator, some of you could probably do that without, 1/2 raised to the 3rd power, 6.25. Okay, so after 1 day, this patient still has 6.25 milligrams of iodine 131. That 131 is just the name. Don't mistake that as some valuable number that you need to use. Okay. Part B says when did the amount drop below 1 milligram? Okay, so that's our future amount. And so when I'm setting up my formula, we know that A, our future amount is 1, P was still 50, and then we know K is still 8, but we don't know T this time. It says when. We're trying to find when it drops below that 1 gram. So I fill in everything I have. We still have the half-life is K, or is 8 hours. And so now we need to solve for T up here in the exponent. That means we're going to need log again. Okay, so your first step here is divide both sides by 50. And don't go to the calculator until the very end. You don't want rounding errors. Okay, and so this becomes 1/50 equals 1/2 to the T over 8. Now this is a pretty ugly exponential expression, but I have a base. Being raised to an exponent equaling a number. And so that means I'm ready to convert to log. Okay, and so it's going to be log base 1/2 of 150 equals T over 8. So log base 1/2 of 1/50 equals T over 8. Now remember, we're still trying to solve for T. And so my last step is just to multiply both sides by 8, and that stays outside the log. And so now, if we have to leave our answer in terms of log, if this is a non-calculator, you would just leave your answer just like this. And then if you do have a calculator, you will type it in. 8 math alpha math, 1/2 is the base. You can do 0.5 if you want to. 1 over 1 over 50. And so that gives me 45.15 years. Remember, t was being measured in years. Actually, just kidding. It's not 45 years. 45.15 hours. We were measuring in hours. Okay, and so if you wanted to get days for that, you could divide it by 24, but I'll just leave it in terms of hours. All right, in this next example, it says the half-life of rubidium-87 is approximately 48.8 billion years. If a specimen currently contains 50 milligrams, how many years will it take for the substance to decay to 18 milligrams of rubidium-87? Round to the nearest year. Okay, so they're finally telling us what to round to. All right, so because we're dealing with half-life, I'm going to go ahead and write the formula. And then some of our given information is we're starting with 50 milligrams. And our future amount we're trying to get to is 18 milligrams. Currently 50, and we're trying to decay to 18. We know that a half-life is 48.8 billion years, so we're just going to keep in mind that t is going to be measured in number of billion years. Okay, and so filling in our information, we have A is 50, we have A is 18, and P is 50. We don't know T, that's what we're trying to figure out, and K is 48.8. Okay, so first step is we are going to divide by 50. And you can simplify that if you want to, but don't round. Okay, now we have our exponent, we have our base, we have our answer. So we're ready to convert. Log base 1/2 of 18 over 50 equals that exponent. So log base 1/2 of 18 over 50 equals t over 48.8. And so now we just need to multiply both sides by 48.8. Okay, and so t is 48.8 times log base 1/2 of 18 over 50. So we can go and type that into our calculator. .8 math alpha math, 1/2 is our base. 18 over 50 is our argument. And we get t is 71.92, and it says round to the nearest year. Round to the nearest year. And so since this is billion years, we're going to do 72 billion years. When it says nearest year, that means no decimals. So 72 billion years. Okay, the last example, an anthropologist has determined that a newly discovered human bone is 8,000 years old. If the half-life of a carbon-14 is 5,730 years, how much of the original amount of carbon-14 is in the bone? Round to the nearest 1/10%. Okay, so I see the word half-life, so I'm going to write down my formula. And then the time, it says it is currently 8,000 years old, and the half-life, which is our K, is 5,730 years. These are in the same measurement of time, both years, so that's helpful. And then it says how much of the original amount of carbon is in the bone. So they didn't tell us A or P, so I'm going to leave those as is. But I'm going to fill in T, and I'm going to fill in K. Okay, and so what we want to do is we want to simplify this multiplier here, 1/2 to that ugly exponent. Okay, and so when I type that in, probably not going to be a very pretty number. 1/2 raised to the 8,000 divided by, still in the exponent, 5,730. Okay, and so that gives me A equals P times 0.38. Okay, and so that, if you just read what this says, it means A is 0.38 times P. I'm just rearranging them. It's 0.38 times P. That means A is 38% of P. When you see 0.38 times P, that's 38% of P. Okay, and so our future amount, A, future amount is 38% of present amount. I believe that answers the question. How much of the original amount of carbon is in the bone? Okay, so the original amount of carbon is P, and we have 38% left. It says round to the nearest 1/10 of a percent, but we would be at the 0, I believe, because it was 0.99. 37.99, yes. So that would be 38%. So you would answer 38%.